This is lesson 4.2, patterns and linear functions. Your objective is to identify and represent patterns that describe linear functions. Some vocabulary. A dependent variable is a variable that provides the output values of a function. The independent variable is a variable that provides the input values of the function. The input is a value of the independent variable. The output is a value of the dependent variable. A function is a relation that assigns exactly one value in the range to each value in the domain. A linear function is a function whose graph is a straight line. You can represent a linear function with a linear equation. The value of one variable may be uniquely determined by the value of another variable. Such relationships may be represented using tables, words, equations, sets of ordered pairs, and graphs. Here's an example. Representing a geometric relationship. In the diagram below, what is the relationship between the number of rectangles and the perimeter of the figure they form? Represent this relationship using a table, words, an equation, and a graph. For one rectangle, we have the base and the height. In order to figure out the perimeter, we'll need the perimeter formula. E equals 2 times base plus 2 times height. When we have two rectangles, we'll count this as the height and this is our base, but remember this line in between does not count because perimeter is the distance around. Same thing for the 3 and 4 rectangles. We're not going to count these lines. It's the distance around the figure. So first we need to make a table. Use x as the independent variable and y as the dependent variable. You will always need to claim what your variables represent. So in this case, we say let x equal the number of rectangles and let y equal the perimeter of the figure. Write each pair of input and output values, x and y, as an ordered pair. So the number of rectangles, represented by the variable x, is 1, 2, 3, 4. The perimeter, represented by the variable y, is going to be 14, 16, 18, and 20. We got these numbers by using the perimeter formula, 2 times the base, which is 1 when we only have one rectangle, plus 2 times the height, which is 6. So our ordered pair will be 1, 14, 2, 16, 3, 18, and 4, 20. Next, we look for a pattern in the table in order to describe the pattern in words, so you can write an equation to represent the relationship. So in words, we can say, multiply the number of rectangles in each figure by 2 to get the total length of the top and bottom sides of the combined figure. Then add 2 times 6, or 12, for the total length of the left and right sides of the combined figure to get the entire perimeter. We can create our equation. Y equals 2x plus 12. Y is our dependent variable, which is the perimeter, and that depends on x, which is how many rectangles we have. So that is the independent variable. Next, we can use a table to make a graph. With a graph, you can see a pattern formed by the relationship between the number of rectangles and the perimeter of the combined figure. First, we need to label our graph. I labeled the vertical axis as perimeter because the perimeter, represented by y, is dependent on the number of rectangles. Since the number of rectangles is independent, we put that on the horizontal axis. And our number of rectangles range from 1 through 4, so I labeled each line as 1, 2, 3, and 4. The perimeter, since it ranges from 14 through 20, I chose an interval of 2, so I did each line by 2s. Now we can graph our points. 1 is at 14, 2, 16, 3, 18, oops, and 4 at 20. Notice that these dots create a line. This is a linear function. You can describe the relationship in problem 1 by saying that the perimeter is a function of the number of rectangles. A function is a relationship that pairs each input value with exactly one output value. You have seen that one way to represent a function is with a graph. A linear function is a function whose graph is a straight, non-vertical line or part of a non-vertical line. Like I said, this graph represents a linear function because it creates a straight line. You can sort of think of a function as the machine that when you put your input, you will get exactly one output for every input that you put into the function. The table shows a relationship between the number of photos X you take and the amount of memory Y in megabytes left on your camera's memory chip. Is the relationship a linear function? Describe the relationship using words, an equation, and a graph. So the number of photos X, we have 0, 1, 2, and 3, and our memory, which is Y, noted in megabytes, 512, 509, 506, 503. So we need to figure out what their relationship is. And when we have 0 photos on our camera, our memory is full, so we have the entire 512. For every picture that we take, we use up 3 megabytes. So we can say that for each picture, X, we multiply it by 3 and subtract that from 512. So our equation would be the number of megabytes will equal 512 minus 3 megabytes for each picture times the number of pictures, X. Now we're going to graph it. I labeled my vertical axis as memory and my horizontal axis as number of photos because the memory is dependent on how many photos I take. On the horizontal axis, I labeled the lines 1, 2, 3, 4, 5. On the vertical axis, you'll notice I used an interval of 2's, but because my numbers are so large, since we're in the 500s, I'm not going to label from 0 all the way up to the 500s. However, I don't want to use larger intervals like 100, 200, 300, 400 because these numbers are so close together. So what you do in a case like this is you will number your tick marks with the proper interval, but because the number is starting at a higher number, from 0 to the first number, you draw a zigzag line to show that there's a bunch of numbers in there, but we don't have the data for that, and we're not plotting points for those numbers. Now we can plot our points. At 0, we're at 512. 1, we're at 509. 2, we're at 506. And 3, we're at 503. Notice again that these points create a line. So this is a linear function.